So the last thing I want to talk about with two-dimensional figures is actually the introduction into three-dimensional figures. And it's the idea that some of our 3D figures can be formed using rotations around a specific axis. Now, the three-dimensional figures we are going to study are the prism, cylinder, pyramid, cone, and sphere. Only 3 of those can be used or can be formed by rotating a two-dimensional figure. And those 3 are the cylinder, cone, and sphere. And what I want to point out to you is the reason why. If you take a look at this, if this segment is the axis, I can't rotate anything and get these right angles down here. So I'm not going to be able to get a pyramid when I do a rotation. Similarly, in a cone, around this axis, now a rotation is going to give me this circular shape or a base. That's what's going to get me, or where I'm going to come from a rotation. If I look at a pyramid and draw in an axis right down the middle, again I'm coming, or a prism, again I'm coming across the idea that I have right angles. Well, you can't form right angles by rotating something around. You can form circles, like a cylinder, a cone, or a sphere. So what we're going to do here is actually take a look at a quick video that's going to discuss this idea.
How do you predict the three-dimensional result of rotating a two-dimensional figure? For example, what 3D shape would result from rotating this rectangle? In this lesson, you will learn how to predict the three-dimensional results of rotating simple figures by analyzing the effects of rotations. Before we begin, let's review 2 concepts. First, a rotation is a circular movement of an object around a center of rotation. Second, in three-dimensional space, objects rotate around an imaginary line, called an axis of rotation. For this lesson, we're going to rotate two-dimensional figures around an axis of rotation and examine what three-dimensional figures result. Hopefully, we'll notice some patterns that will help us predict other rotations. Let's start with a simple figure, a triangle. If we rotate this in 2 dimensions, it would move like this. But in 3 dimensions, we're going to rotate it around an axis. Here's our axis bisecting the figure. Now let's watch what happens as it rotates. It's interesting to see that the edge that was perpendicular to the axis drew a flat surface as it rotated. And the other 2 edges, as they rotated, created a curved surface. So, the rotation of a triangle creates a cone if the axis of rotation bisects through a vertex. If we place the axis along the edge of the triangle, watch what results. The edge that overlaps the axis provides the top and bottom extremes of this solid, and is the axis of the shape. At the same time, as the other 2 edges rotate, they create curved surfaces, pointing away from the axis. Let's try this with a rectangle. Watch this rectangle rotate and pay attention to what surfaces are created. Do you notice what's happening? The edges that were perpendicular to the axis of rotation rotated, drawing out flat surfaces. The edges that were parallel to the axis drew curved surfaces. This rotation created a cylinder. So, what do you think will happen if we orient the axis a different direction? Here's that same rectangle with a different axis of rotation. When we rotate around this axis, notice what happens. Again, the edges that are parallel to the axis create a curved surface, and the edges perpendicular to the axis create flat surfaces. A cylinder is the result again. So, does that mean that every time we rotate a rectangle, we'll create a cylinder? Well, let's find out. What happens if the axis of rotation is oriented diagonally across the figure? Before rotating this rectangle, let's try to predict the result. None of these edges are perpendicular to the axis of rotation. So, as it rotates around the axis, we won't get any flat surfaces like we did before. Everything will be curved surfaces that angle away from the axis. Let's watch. Was this what you predicted? What is really interesting about this rotation is that some of the edges overlapped with others, but we're only observing the outer faces. So, what about rotating a circle? Now, clearly this is not an actual circle, but stretch your imagination with me. Let's think about how this would rotate. If this were a circle, there would only be a curved edge, right? In fact, rotating this will create curved surfaces, and it'll be a sphere. Of course, placing the axis of rotation tangent to the circle's edge will result in a different figure. In this lesson, you have learned how to predict the three-dimensional results of rotating simple figures by analyzing the effects of rotations.
So that video does a great job of illustrating exactly what is happening when we do these 2D rotations and what's not happening as well. The only thing that's left for us to do is get some practice in actually drawing that rotation. So in all of these instances, our little dashed line is going to be the axis that we're rotating around, and the solid shape is going to be the figure that we are rotating. So from the video we learned, if I'm rotating a rectangle, one of the things that I would say that could make this easiest is try to draw first a recess of your rectangle, and then, as they mentioned, anything perpendicular to your axis is going to give you a curved edge. So I'm going to curve this edge and curve this. I'm going to dash this line, and we'll talk a lot more about dashed lines when drawing 3D figures as to what they represent. Once I have that reflection, I have my full image. I just need to draw those curved edges, and we get a cylinder. Same idea in a problem like number 2, except I don't have to draw the reflection. The reflection is already there. It's just a matter of drawing my curved edges. And I'm going to dash this one, and again, we will discuss why. But be careful, because sometimes we switch that axis of reflection. In this case, it's a horizontal reflection. So I'm going to draw my reflection here, so it's a horizontal rotation. Now my curved edges are going to go this way, and I'm going to have my cylinder looking that way. It's on its side. Similarly with triangles, if I have my reflection, I'm in good shape. The only segment here that's perpendicular to the line of reflection or of rotation is this base. That's the only one where I have to draw my curve, and I get my cone. In a problem like number 5, I want to make sure I draw the reflection, and it has to be somewhat accurate. This is my only perpendicular, that's my only curve, and I get my cone on its side. In number 6, it's the reflection and then the curves. I have a cone. The back, we start talking about circles and hemispheres. So again, the best course of action at this point would be to try to somewhat accurately draw your reflection. Now, to draw that this is not just a circle but 2 dimensions, I would say draw a curve this way and this way. That makes it look a little more 2-dimensional or 3-dimensional. Okay, get some more practice. So again, perpendicular to my line of reflection and rotation, I'm going to draw a curve and a curve to give it a bit of a 3-dimensional look. Okay. The video and a bit of my explanation will sort of kind of give you guys an idea as to what happens here. Will a rotation around an axis ever form a prism or a pyramid? And the answer is no. And using the terminology in the video, it can tell you that it's because you're always getting curved edges, and prisms and pyramids do not have curved edges. And for number 11, it says that a rotation will not always form a sphere, cylinder, or cone. We saw that in the video. We saw some interesting solid figures being formed. And the major thing that you have to do in order to accommodate that is to make sure that you're not always having perpendiculars to your line of rotation, your axis of rotation. So example might be something like this. That's a segment that's not perpendicular. If I draw another segment that's not perpendicular, if that extended down, I have nothing that's perpendicular here. So my rotation, well, first, if I reflected it this way, the rotation would look like this. It's almost two cones on top of each other, but it's not a cone, and it's not a cylinder, and it's not a sphere. Our last question says to draw the two-dimensional shape that will form a cylinder when rotated around a given axis. If yours doesn't have your axis of rotation, draw one in. I drew mine horizontal. And if I want a cylinder, I need to make sure I draw a rectangle. That, when rotated, assuming I have this at a line of symmetry, will give me a perfect cylinder.